Pt.1. These are power series and radius of convergence. That's the formation of the power series, but you see that C sub n? I don't want you to think that's just a constant. It means that C sub n can involve a -1 to the n. It could have a monomial in it, like an n cubed. You could have a 3 to the nth in the denominator. So all that I'm putting my hand over would be the C sub n. And then there's this variable x raised to the n. And everything's about the x. We're going to figure out when does this power series converge for different values of x. So it's all about that variable x. There's a lot of letters in there, right? N's and x's. But we're determining it for the variable x. So when I say determine the radius of convergence of this power series here, and the interval convergence, we're talking about the variables x. What numbers for x make this converge? So that's why I'm going to go over here, that x there. I'm just going to change the color. So you know when they're talking about, what are you talking about in terms of the radius of convergence? That's the variable x. What numbers could we substitute for x? 2 or -1/2 or something, and that power series will always converge. So to do this, I think you'll like this section. We're going to do the ratio test repeatedly. That's all we're going to do. So you can make a note with 11.8, we're always going to use the ratio test. So we'll use the ratio test to determine what values of x make it converge in that radius of convergence. So we use the ratio test. We should briefly review that at the beginning. What was that? That's where we had to see the limit as n approached infinity. We did the a sub n plus 1 of this sequence here, the sequence being a part of the series, divided by a sub 1. We took the absolute value, and when did this converge? When this limit was? Great memory, less than 1. That's what we checked. So over and over and over. Let's just leave this up the entire time for section 11.8. We're just going to use the ratio test to determine the variable, the numbers of x that make it converge. Something else comes up in this section you might not have seen since an intermediate algebra class. It's not hard, but something like this at the very end. I'm just going to make this up. Algebraically, do you know how you can write this without those bars? It's not hard. They call this an absolute value inequality. It's taught in an intermediate algebra class. So if you haven't done it, it could have been like years ago. But this can be written as, you put another arrow over here, and you put a -2. So this means x is between -2 and 2. So we'll do that over and over again. I just want to point that out. So, but it might have been a long time since you did this, or you may have never done that. It's taught, that's where it's taught. It's not even like in a college algebra. Well, sometimes we put it in college algebra. Hey, so what would this be? I'll make up another example. What if it was x minus 1, and this was a 3? So how would you set this up? X minus 1, take the bars off. There's your 3, what goes on that side? And then you solve for the x in the middle, right? Just dealing with the inequality. You want add a 1, add a 1, add a 1. So what do you get for x? What's in between? A 4 and 2. There you go. So that's something we'll do at the very end. When they talk about find the interval of convergence, so be the last step. You'll just go, oh, let me just. But that might have been new to you. I mean, that's where that's taught. You're like, I've never seen that before. They call them absolute value inequalities. So that comes up every problem we do. When it comes down to the end. You go, why? Because there's bars here. See the absolute value bars? And we're going to have that variable x. So those bars are going to go around that x. And that's why this is going to come out in the end every time. Every time you'll have an x with that bar around the end. All right, so this is the first problem we're going to work together. We're going to use the ratio test to determine the radius of convergence. So what we mean by that, what values of x make this series here converge. So let's start out, we'll get working on it. Let's do the ratio test. All right, so I'll use the ratio test. I get the limit. As n approaches infinity, we put the absolute value bars. -1, let's start out. That would be -1 to the n plus 1, so far so good? I want to take this slow. How do you write n cubed? So I replace n with n plus 1. So is it this, or is it this? Just to make sure everyone's comfortable with the ratio. It's this one. Oh, good, you got it. I'm gonna put that down. Everyone, very good. That's what we mean. That just stays x to the n. We put x to the n, we put a plus 1, right? So far, so good from substituting n plus 1s in the top. But now I got the what? There's still a what? 3 to the n, so that's 3 to the n plus 1. All right, we're good to go. A sub n plus 1 is complete. Now I got to put this all over what? A long fraction bar. And what's this all over? I just repeat the expression. All right, negative 1. N cubed, x to the n. All over 3 to the n. Absolute value bars. And when will this converge? I might as well put it over here. When this entire limit is less than a 1. So you'll do that on every problem. When you determine the radius of convergence, you're always trying to find out when the limit's less than 1. Not a 0, it's always going to be less than 1. Remember, this test is inconclusive if it equals 1. Hey, to save time, how do you divide fractions? You might do this automatically in every problem. I notice students do this all the time. This took a lot of writing, do you agree? And sometimes when you got to write so much, it can be confusing. I might make a typo or write the wrong expression. So I am just going to put this next to it and flip it, right? I'm just going to take this, put it right here and flip it. So I'll just use my eraser. Is anyone still copying that? But you might automatically go to that spot. I know a lot of students do that to save time. They're like, I'm going to have to divide this, so I might as well just put a dot right here and flip everything over. That went here. This went down here. This went here, and this is that x to the n. There we go. I'll put bars around the whole thing. And this one is less than 1. Almost done. Now it's just simplifying, true? Hey, I'm going to highlight. Where's the x? So it doesn't get lost. I think you'll love this section. We just got to be organized. I see it right there. So I just want to highlight it where it is so I don't lose track of it. There you are. There you are. Okay, I got you. I got you. I see where you are. Because it's all about the x. The problem's all about the x. Okay. You ready to start simplifying this stuff? Do I even have to worry about these negative 1s anymore? Do you want to just scratch them out? I mean, you can write this as negative 1 to the n times negative 1, but what's around it? Absolute value bars. What's the absolute value of negative 1 always going to be? 1. So does everyone just want to scratch yours out right now? Okay, let's do it. You're going. I'm just going to look at you, because the absolute value of negative 1 to an n plus 1 or negative 1 to the n, sure, I can write this as negative 1 to the n times negative 1, but we're saying all you're going to get is a negative 1 to the first power, and the absolute value of negative 1 is just what? 1. Cool. Leave that as is, because we're not expanding that, are we? Do not think you got to expand that. Leave that n plus 1 cubed. How can I rewrite that, though? And some of you do that right away, and that's okay, too. Some of you just you do 2 steps, 3 steps at once. That's x to the n times up x. How about that? 3 to the n times 3. So far, so good? You got the dot, you got this, you got a 3 to the n. You got your n cubed right there. X to the n. We're staying organized, nothing's missing, right? All right. Let me highlight my x's again. Whoop. Whoop. There they are. All right, we'll cancel. X to the n's are gone. Bye-bye. But that little x stayed, right? By the way, that will happen every time. 3 to the n's. They're gone. And this is what we got, right? Now this is how I'm going to write this next statement. I'm just, since the focus is that x with an absolute value bar around it, I'm going to put that in front of here, way out in front of the limit. Just because that's our focus. I'll put it way out in front of the limit as that approaches infinity. You go, can I do that? Yeah, does that have an n in it? Do you agree? So I'm going to write that right in front of this. So you and I can focus on this limit. All right, what are we left with? there's an n plus 1 cubed. We pull that outside here, right, with bars. What else is in the denominator? A 3 and a n cubed. And we're trying to determine when this limit is less than a what? A 1. So I'm going to write that again. Cool, Jessica.
Can't you divide the n to the third? Can't you divide the n out of the parentheses 3 times?
I wish. The only way we could kind of look at this another way, Jessica, is if we expanded that thing. You know, like a m plus 1, then an m plus 1, then a... And we're like, oh, good golly. There's no need for that. Because we're just trying to get a limit. So we can either look at the Horace, or we can do L'Hopital's rule. If you're a L'Hopital rule fan, L'Hopital's rule, go ahead and do L'Hopital's rule on that limit, right? If you're like, I like to just look at the horizontal asymptote. Does anybody know the Horace? Because the powers are the same. It's going to be the coefficient, which is 1/3. Now, if you don't see that, you can do L'Hopital's rule, where you just take the derivative of the top, derivative of the bottom, you'll eventually get there. Anybody want to see L'Hopital's rule real quick to see that limit's going to be 1/3? Let's see. What's the derivative of n plus 1 cubed? 3 times 1 squared. What's the derivative of the bottom? 9n squared. So far, so good? Now, I still get infinity over infinity, so do the derivative again. L'Hopital's rule. Take the derivative of the top. What do you get? 6 n plus 1. What's the derivative of the bottom? 18n. I still get infinity over infinity. So now, take the derivative of the top. I'm going to show you that. And the derivative of the bottom. What's that derivative? I'm just going to keep doing L'Hopital's rule here. What's that derivative?
6 over 18.
Which is? Cool. So if you're a L'Hopital's rule fan, you don't look at that horizontal asymptote of these rational. You didn't recognize it was a rational expression. You can always do L'Hopital's rule to find those limits if you're a L'Hopital's rule fan. But there's no need to go expand that thing, right? That's why. Hey, but some of you might realize, oh, that's just 1/3 the horizontal asymptote of that rational expression. So, this is what I have now. I have an absolute value of x. I'll put it in yellow. What's this entire number right here? So I am going to substitute just a 1/3 there. This is all gone, but what's still over here on the right side? Less than 1. Put this down so we can see it. Less than 1. That's our math problem. And I'll rewrite it over here. Can I erase the L'Hopital's rule work? Yeah. So let me write this again. What are we left with?
Absolute value x.
Absolute value of x.
1/3.
A 1/3 and a left one. We're about to get the radius of convergence. To get it, you got to isolate this absolute value of x. That's all you got to do. So how do you get that 3 off that denominator down the right side? Multiply it, right? Hey, when I multiply, do I have to switch the direction? No, that's only when you multiply a negative number, right? Now, there it is. That's the radius of convergence. That number right there, and you'll see it. We just found the radius of convergence. It's a 3. You could write r equals 3. But I encourage you to draw a number line. I don't know if you'd find this in the textbook, but can we talk about these x values? Because we just found the values of x that make this converge. Can we draw this on a number line? Sure. Take off the bars. I can put a 3 here. What do I got to put on the other side?
-3.
Good job. You just solved the absolute value inequality. What's that look like on a number line? Just so we can look at these numbers. You just found all the values of x that make it converge. What's centered in the middle? 0. What's on this side? 3. And what's way over here? I'll even put tick marks. -1, -2, -3, 1, 3. And you're saying all the values in here for x will make this converge. Cool. But do you notice what I mean by, and I'll get your question wrong, Connor. Do you notice what I mean by radius? Like the radius of a circle, you go from the center what? Out. Let me say that again. Radius of a circle, you go from the center out. So if you go from the center out, what's the distance? 3. So maybe a better way to say this. Radius convergence. It's a radius of 3, and then I'll write this. Centered at x equal to 0. The book calls x a. You could say centered at a equals 0 or x equal to 0. We're just talking about, what values make that converge for that. So Connor, go ahead.
So you just divided out the 1/3, right?
That right there, what I did, oh yeah, you could think of it that way. Divide a 1/3 on both sides. That will work.
Okay.
So when you divide a 1/3 here, it becomes a 1. A 1 divided a 1/3 becomes a 3. What someone else suggested, and this is up to you, they said, why don't you multiply it through on both sides? Right now, that's what he said. Both of them work though.
If you multiply, would it be a third?
Look what would happen. So you multiply a 3 over here, then you multiply a 3 over here, and they would cancel.
Oh.
But what you said was fine. You said, I will divide 1/3 on both sides. That works too.
Okay.
And I'll go back to write it as is, but Connor, if you prefer that division of the 1/3 on both sides, that's totally fine.
Thank you.
All right, man.
X isn't always 0, right? It's just whatever's in the middle of your 2.
That's right. And so this problem, this had an x here, centered at 0. That would be centered at 0. And my next problem, you'll notice it won't be centered at 0. And you go, what makes it not centered at 0? And you'll be able to tell. You could look, you could see it right away at the beginning of the problem. Dave.
Isn't it because of when you move whatever's there to, when you don't, I guess, normalize it?
That's right. That's exactly why.
So if you were to have like x minus 1, it wouldn't be centered.
You just answered the question. Mandy, does that make sense? He says
Yeah.
if that problem started with a, right here, like a, okay, that thing's going to be centered at 1. I can keep going. What was x minus? Centered at 3. Just if you want, anybody want to be able to spot it from the beginning. X minus 5, that would be centered at 5. Hey, a trick question. What if it's x plus 5? It's centered at negative 5. But when it's just a x to the end, it's going to be centered at 0. Hey everyone, we got it. We found the radius convergence. You can just write your answers like this, r equals 3. That's what you're going to see when you look at Bob. Bob's back a book. When you look at Bob, it's going to go capital R equals 3. One more thing. We got to talk about this interval of convergence. Well, don't we have it? Yeah, but we should check the endpoints. Maybe we could put an equal sign here. Or maybe we could put an equal sign here. So we're going to check the endpoints just to make sure. It's not a big deal. Don't think it's like, oh gosh, more work to do. We're just going to do this. We're going to take that number, go to the original, plug it in for x, and see what happens. Just examine it. Then we'll come back, we'll plug in negative 3 into that original, look at it, see does that converge. Okay? So we're now going to determine whether or not I can put in equals here and equals here. It's not a big deal. And when you've done, to me, you've done what? 98% of this problem. 98%. We just got 2% left. I'm just going to check what? That number and that number to see if we can put equals on. So you ready? You want to start with the 3? Let's go up there. Let's check endpoints. Check the endpoint, x equals 3. So what do you do? Plug in a what? And I need to just examine this. You got negative on the end, n cubed. You got a 3 to the nth, all over. Just examine it. You do not have to do the ratio test here. Just examine it and tell me your thoughts on this. Does anything cancel? The 3 to the n's cancel, huh? Now does everyone see what I did? I just simply plugged this 3 where? For x, right? Maybe I should color code. And again, this is not a big deal. You're just going to check these two numbers in the original series. All right, what cancels? Whoop, whoop. Now tell me about that series. Would that converge? If it converges, we get to put an equal sign. So I want you to think about that. Negative 1 to the n cubed. Start plugging in like gigantic numbers. Everyone, isn't that thing diverging? I mean, it's going to be plus and minus, and n cubed means it's sending towards what? Infinity. It's going to be infinitely large, and it's also changing pluses and minuses. So it diverges. You know, if you wanted to write something out here, you don't have to. But if you want to write, well, that would diverge by test for divergence, which it does. But we can't use 3. So I'll just put a sad face. 3 is no good. Can't include which number? X equals 3. If you want me to explain, let me say it again. Why did this happen? Why is this series divergent? This diverges by the test for divergence. The limit, as n approaches infinity, that is not existent. Okay.
Wouldn't that kind of follow because of less than signs are less than or equal to, so that they just exclude those values?
That's right. Very good. Hey, what's the other endpoint?
-3.
All right, well, let's check that. Check this endpoint. Now, when check endpoint, x equals negative. All right, let's play it out. Check the endpoint.
Same one.
X equals negative 3. So what would this series look like? I would have a n equals 1 to infinity, negative 1 to the n cubed, and then negative 1 to the n? Or negative 3 to the n, excuse me. Let me color code that. I'm plugging it in right there for x. And a 3 to the n. And then you and I are going to look to see how this plays out. And I'll move this so we can have more work. Probably as this, I can draw in there and go. Absolute value of x is less than 3. Means x is between 3 and negative 3. There we go. But we're just investigating whether or not we can put equal signs here. We already know we can't put an equal sign here, right? What about the negative 3? Now, anybody know how I can break that up? We gotta be able to break that up. I want to break this up so I can cancel it through the n's. Do you know how to do it?
-1 times 3.
I'm going to do it. So when n equals 1 to infinity, leave that. Leave that. He says make it negative 1 to the n times 3 to the n. That's something you'll do often in the next, we're in section 11.8. 11.8 to 11.10. That's something you will do often. That you'll say, I can rewrite negative 3 to the nth as negative 1 to the n times 3 to the n. And that's just by the rules of exponents. Oh, Dave, go ahead. You had a question.
Never mind.
Oh, you good? Oh, cool. Hey, what cancels?
3.
All right, these are gone. Now, what's that times that? Bases are the same. You can add the exponents. So that would be negative 1 to the, what's n plus n? I'm okay with that. I'm using the rules of exponents. I can add, I get the same bases, add these up. But negative 1 to the 2n, hello. Won't that always be a 1? Try it out. Put a 1 in there. What do you get? Negative 1 squared. You put a 2 in there, you get negative 1 to the what? 4. This is always going to just be a 1, isn't it? So I'll rewrite this. But I think we all know that does not converge, does it? That's divergent. That's going towards infinity. Diverges, if you want to know why, by test for divergence. So after we spent all that time, thanks for bearing with me, we checked this other endpoint. We can't put equal signs. That's the answer. Some of you might eyeball it, you know, but you gotta put some scratch work down, write some, just to check it out.
So the checking the points is actually just to confirm or whether or not you're adding equals?
That's right, that's all it is.
Okay.
And I'm being honest, like, don't let it overwhelm you. I'm saying 98% of this problem was to seriously get this, everyone. You've accomplished a lot, right? That's the big deal. You got the radius. You know where it's centered. You got an idea of the numbers that make it work. Now you're just checking what? Can I include those? Can I just include those and put an equal sign in this? And we just discovered I'm not allowed to do it, am I? Sad face on both of these. I'm not allowed to use the negative 3. It doesn't work. And I'm not allowed to use the 3. So, hey, sorry. I can't put an equal sign there. That's the interval. Just so you know the answers. This is that interval of convergence. And what's the radius? 3. You don't have to put centered at 0, but I always write that, Amanda, just for clarity, so you can get an idea. Oh yeah, what radius means. Look, I go 3 that way, and I go 3 that way. Cool. Now wait till everyone's done copying, and we'll do another one. But you got it. How about this section? Every time we do the ratio test, and it comes down to the end, then we'll just check those endpoints. Now race. Cool. All right, here's the next one. Hey, I wanted to make sure pick a bunch of problems that really kind of reflect the homework practice problems. That one was like number 9, if you're curious. This one's also like number 9, but it's based off what Dave and Amanda are asking about. So all I'm going to do in this problem, everyone, is change little things. Maybe this one doesn't have a -1 to the end. Need the directions. We'll figure out the radius. All right, here you go. Power series. Does this start at 1? They either start at 1 or 0, you'll notice. They don't have to, they could even start at a 3 or something. But it's got an n squared. It's got an x minus 2 raised to the nth over 4. Over 4 to the nth power. There's the power series. So they call this a power series. The C sub n is all that junk right there. That's the C sub n. So, oh, this x to the nth can be x minus or x plus a number. Cool. So hey, again, I'll highlight where this x is. There it is, but now it has a what? Yeah, so that's the key. So when you know what you're gonna have in the end, and like your, I'll call it the penultimate step. In your penultimate step to the problem, you're gonna have this written. You'll have something like this, and you'll be getting that limit, just like before. There'll be a limit in, goes infinity, there'll be a bunch of junk here, and you'll be writing this. That'll be the second to last step. You'll find that limit, and then Connor will just, should we multiply it on both sides or divide a number? That's what it boils down to. So that's what I mean, Amanda, or anybody, if you like, there's a lot of writing involved. If you can do 2 steps at once, that's actually okay. That's actually okay in terms of just write that limit as n approaches infinity and go to work. Are you ready to do the ratio test? Let's bust it out. Now that'll be the second to last step right there. It'll just be some stuff in there. We got to figure it out, right? All right. So when I'm looking at doing a ratio test, what's that become? Is it n squared plus 1 or n plus 1 squared? You all are awesome. How about this next part? All over? Way to go. And up at the bars. Did I forget anything? This can happen. When I did so much writing, you're on a test. I did so much writing, I might have forgot something. So I have to divide this by a sub n, right? Okay. So this is where I'm going to put a bar here and put everything down here. But Lottie, if you want to save time, what are we going to do in the next step anyway? Put a dot and then flip it. So I'm going to do that. Put this bar here, dot it, flip it, that goes up there. Here comes the a sub n. Let's get it down here. If you want to highlight that x minus 2 again, you can. And we're determining when this limit is less than 1. Ratio test. That'll be our second to last step. Why? Because what happens here? N plus 1 squared. Do you have to FOIL that out? No. What's that? X minus 2 times up to the n times up. Cool. 4 to the n times up. 4. For the n, that's an n squared, and that's an x minus 2 to the n. I don't want to rush you, but is that okay how we got that thing simplified? About slash time, slash it out. Slash away. The worst is when your eyes miss a simple number like that, because that 4 right there will really affect our limit. So don't be knocking that 4 out, right? What goes out? You're out. You're out. This is out. This is out. That went just like we expected. Guess who's hanging around? This 20x minus 2 with the bars on it. So I'm going to put this out in front of this. Just get it out of the way. That's our focus. We'll have that at the end, but now we're getting this limit. It's just a limit problem. I can take off the bars, everything's positive, what do you have? 1/4 of n plus 1 squared over n squared. No need to expand that. You could do L'Hopital's rule or think of the Horace, because that's a rational expression. What's that limit? 1/4. That limit's 1/4, isn't it? So now, you know what's neat? I said that's the second last step. You were right here now, and you just figured out that limit. This limit, right there, is 1/4. X minus 2 with bars on it times the 1/4 is less than 1. I'll go to you, Connor. It's up to you. You want to divide 1/4 or multiply 4? Either way you want to say it.
I like dividing
So this is what he does. He goes, I divide 1/4 on both sides. Now, if this had a 4 here, he would have divided a 4 on both sides. So he's thinking always division. That's a great way to roll with this. But when you divide a 1/4 from a 1, what happens? You get x minus 2 less than a 4. So I'll erase this, everyone. I know the radius already. The center is not 0 anymore. Where's the center? Yeah, x equal to 2. The book likes to call it a for some reason. If you want to write a equals 2, that's the center. Right, center 2. What's the radius? It's on the other side. What's the radius? 4. So will this always be the radius over here? Sure. I want you to see it. Let's see why. This will always be your radius. Centered at, pick the opposite sign. So centered at x equal to 2, a equal to 2, with a radius of 4. What would this look like on a number line? Well, we're going to look at the interval too. Less than 4 and greater than a negative 4 is going to be my next step. I don't want to write that yet. Someone help me take these bars off? I pull them off, what goes over here? Negative 4? Like in an intermediate algebra class, an absolute value inequality. Now solve for x in the middle. The highest it gets to is 6. What's negative 4 plus 2? Negative 2, good. And look at the number line. I like to just draw it out. All right, went to a negative 2, and then negative 1, 0, 1, 2, 3, 4, 5, and 6. And the center is where? Yeah, and here's the center. And how far is it? Either way, the radius is what? The radius is centered at 2. So the back of the book would write this. R equals 4. But there's one last thing left to do. Think of it not as tedious. It's just you've done really 98% of this problem. Can we check those endpoints again? You know, it's like just checking them. Put the negative 2, put the 6 in there. And this time, I'll start with a 6. If I put a 6 in there, this time I don't have to write as much. We'll simplify it. Look what you get.